Hello, how are you? Let's talk about energy. Energy is the theme we're going to talk about, and universe is full of energy. Universe has matter and energy. Two different things. Einstein has given his famous equation E equal to mc square, where E is energy, m is the mass of the matter, and c is the speed of light. So c square. So it's a huge number. Whenever we convert matter to energy, we can get a lot of energy out of the matter. But is it so easy? It's not always easy to get energy the way humans want it. So sun itself has enormous amount of energy that it radiates every day to Earth. So from humans perspective, we have a perennial source of energy for millions of years. So let's see how we can try to correlate some of these ideas related to energy, and we have certain concerns also in the human civilization right now about energy in terms of energy crisis. All humans do not have enough energy available daily needs for whatever they want to use it, whether it's computers or it's heating the home or for fans or for air conditioning or for any other operating any machinery. Humans need electrical energy or other forms of it. So energy is a theme. Let's talk about, let's go over a few details, what we can understand about the current energy crisis, or when we can possibly resolve it, how we can possibly resolve it, and various ideas related to these. Forms of energy. Energy comes in various forms: chemical energy, electrical energy, nuclear energy, also potential energy, kinetic energy. So let's go over some of the things in terms of what forms of energy is available for human utilization, and how we can use this to meet our needs, at the same time not spoiling the environment, keeping climate in a reasonable shape, so that our future generations can continue to enjoy their stay on energy. Energy in the universe. There is unfathomable amount of energy in the universe for human needs. Human needs are so minuscule that compared to the total energy in the universe, human needs can be met very easily. However, we have an energy crisis. Why? What crisis do we really have, and can we really address this before it becomes serious enough for humans' survival on Earth itself? Let's take a look at a few of the factors and how we see this energy crisis evolving, and what context are people talking about. Einstein formulated the most famous relationship between matter and energy, E equal to mc square, where E is energy, m is the mass of the matter, and c is the speed of light. So we can realize quite a large amount of energy from the matter that is existing in the universe. From every part of the matter, can we really realize energy? That is a question. So a lot of these science questions need to be understood, and then we need to see what we can do for the current humanity. So matter can be converted to energy, and energy gets stored into the matter for future use. So let's look into some of these aspects. So we can produce a lot of human energy for human consumption on Earth itself using the principle that Einstein gave us, equal to mc square. However, there are side effects, especially for nuclear energy, nuclear fission if we do it. So a lot produces a lot of waste material that we do not know how to manage it. So that's what we mean by side effects. States of energy. Energy comes in two different states. One is kinetic energy, when things are moving. Energy is in that form. Potential energy, stored energy that can be converted later into some kind of kinetic energy to move things. Earth's own energy. So let's try to understand what type and amount of energy is available on Earth itself without any external sources. So Earth itself has a lot of sources of energy. So what are those sources? Let's look into some of those things. Earth itself has kinetic energy. Earth moves, it revolves, it rotates, so it has kinetic energy. So we do not directly use this Earth's kinetic energy. So are we really sure that we do not use? Do satellites use this energy to stay in orbits? This is one of the aspects that we need to understand. How do we get tides in oceans? Is it because of Earth's rotation, or is it because of Moon's gravity force? So what type of energy is being transferred from Moon? Moon has kinetic energy. So is that energy being transferred to Earth through gravity, and then the tides are coming in the oceans, which we could possibly use for generating electricity. So these are the kind of different things. So Earth itself has energy because it rotates and revolves. And then there's a lot of potential energy on Earth. That means there's a lot of stored energy on Earth. And what forms is this energy stored? The most common things that we are aware of right now are fossil fuels, that's stored chemical energy. So that's coal, oil, gas. So we know how to use this. Is it only in the last 100, 200 years since the Industrial Revolution that we know how to use this? Not really. Humans have been using coal for quite some time. Romans themselves have started to use coal. So we are not new humans in the recent generations to start using some of these fossil fuels. So fossil fuels have been in use by humans for quite some time. The other forms of stored chemical energy or stored energy on Earth is geothermal energy. Earth's core itself is molten iron. There's a lot of heat trapped within Earth itself, Earth's core. So that gets released sometimes, can be possibly be used. And there are places on Earth like Greenland where geothermal energy is tapped and utilized very well, including even Hawaii. So nuclear energy is another thing. There are nuclear materials available on Earth, even if it is in limited quantities. We have tapped into this resource and built nuclear reactors and started generating electrical power from the nuclear energy. However, there have been a few issues because of which it's not widely used. And apart from all these resources, do we have any other sources of energy on Earth? The interesting thing is Earth gets energy every day. From where? Most of the energy added to Earth's own local energy sources, it's either solar, comes from sun, either in the form of light or heat. And also the kinetic energy of the moon gets stored into the tidal energy of the oceans. So now the question is how much energy is really coming from sun itself. So if you look at solar energy, thousands of terawatts of power is being transmitted to Earth every day from sun. So if you look at this picture, the incoming sunlight is about 174,000 terawatts, out of which there's a lot of dispersion. Not all of it reaches Earth's surface, and 89,000 terawatts is absorbed by land and oceans, and some of it is absorbed by the atmosphere, and again some of it gets reflected back or radiated back into the space. So as you can see from various figures here, there is enough amount of energy that is trapped in Earth's atmosphere or in Earth's crust or in Earth's oceans. So this is stored solar energy. So whether humans are doing it or not, solar energy is being stored every day by Earth. And a lot of organisms on Earth, whether it's living or even non-living things. So that way water, even Earth's crust, there are so many non-living things, or rocks, or sediments, so many other things are storing energy. In what way? How? So do we really have energy crisis? What crisis do we really have? So no matter how large human demand may be, we can easily meet that demand if we can utilize solar energy either directly. When we say directly, that means capturing the solar light energy using photovoltaic cells, or thermal, the heat energy from the sun rays, that's directly on Earth, the terrestrial use. Or can we do this on space? Because a lot of it is getting reflected back into the space. So if we capture it right within the space, outside Earth's atmosphere, the space-based photovoltaic capture of solar energy, there is a lot of potential, there is a lot of research going on in that. So there's virtually unlimited amount of energy that is being supplied to us from sun for human needs specifically, and the rest of the Earth's organisms and atmosphere itself. So the indirect uses of solar energy can be through water cycle and through weather cycles, because of which there is wind power, there is hydro energy, hydroelectricity that can be generated because of the water cycle, and then the biomass, because whether we store the energy or not, plants store energy, and eventually they can be part of the biomass cycle. So when we look at solar power, massive orbiting solar panels can collect energy. That energy can be sent back to Earth, and then earthbound receivers can capture it and then provide it to the local towns and cities. And solar energy is automatically stored in a lot of different ways every day. One of them is the food chain. So we learn about the food chain early in primary school itself, and then we do not realize that it is actually solar energy that is being stored. Photosynthesis is the primary mechanism through which solar energy is captured by the plants and stored and as chemical energy, which is food, which humans and a lot of other animals use it. So the entire food chain itself is sun dependent, solar energy dependent. So this is an organic use of solar energy. When we talk about so much of technology, so much of nature already has the organic way of storing the energy and utilizing the energy on this earth. So the other ways the solar energy gets stored is the weather. Whenever there are heat differences because of which you have these winds, whether they can be hurricanes or they can take the form of or typhoons or monsoon, and then the water cycle, water gets evaporated from the oceans and then becomes clouds, and then we get rain, and that is actually potential energy. So when the rain falls and the water gets stored in higher land areas and then starts flowing down the rivers, we can build the dams and then try to generate hydroelectricity. So how did the water move up there? It is because of solar energy. So that way solar energy is automatically getting stored and for utilization at a later date and later time, that we can still store it by building dams and reservoirs. Of course it does affect the environment a little bit, but we need to assess the good and the bad and then do careful designs of all these dams so that it supports both humans and the rest of the environment in utilizing the solar energy efficiently and responsibly. So other forms where the solar energy can get stored is the plants, biomass, where if the plants are not utilized for human consumption, they eventually die and then they can be part of the standard food chain, or they can actually be stored for energy itself. And when we talk about space-based solar power, it's not ready. It will not be ready for a few decades, and we need to utilize terrestrial sources only. What do we mean by terrestrial sources? That means earth-based sources. That means we have to capture solar power on Earth itself. We cannot do this in space yet because we do not have all the technology and the science that is needed to generate and capture the solar energy in the space itself and transmit back to Earth in an efficient way and in a large scale to meet all the human demand. So right now we are trying to do it right here on Earth using photovoltaic cells or thermal way. So we need to use other forms of terrestrial sources. One is of stored energy or renewable energy. So all renewable forms of energy are based on solar. So we've discussed either the food chain or the biomass or the weather cycles. All of these are primarily solar based, solar energy based. While the space solar is not ready, what we can do to capture the solar energy right here on Earth in a non-traditional way, or what nature doesn't automatically do. So that's where we do photovoltaic. Terrestrial photovoltaic is not that efficient. It's been tried for the last 30-40 years, but it still hasn't achieved the level of efficiency to meet current human demands. So science and technology advances are still needed for photovoltaic solar energy capture locally right here on Earth. And apart from photovoltaic capture, we also need to use other forms of stored solar energy on Earth. That is whether water cycles or weather cycles, which are wind or biomass. For all of these things, the primary issue is infrastructure. So if we need to generate more hydroelectricity, we don't have to really build huge dams like the Three Gorges dams. So we should be able to generate enough power for local communities from out of the flowing rivers. So why are we not doing that? That requires quite a bit of engineering process and infrastructure build out. That has not happened on quite a few parts of the earth. So a lot of the developing countries require to do the local research needed to develop this infrastructure and build out this infrastructure so that they can use other forms of stored solar energy, like whether it's hydroelectricity or even wind or other kinds of biomass. So apart from all of these solar energy based ideas, while there are a lot of ideas about energy utilization for human needs in the long term, like space-based solar power and other renewable sources right here on Earth, we are still a few decades away from really achieving that goal. So what do we do in these next few decades? Our hope is to continue to use all the potential energy that is stored right here on Earth for the last few million years. So some of those are fossil fuels, which is coal, oil and gas, and geothermal and nuclear. So So that means we're going back to all the known methods of extracting energy for human consumption through electrical energy generation and then transmitting it, utilizing it in our cities. However, there are issues in using these traditional fossil fuels, not only that these resources are limited, but also that they might be causing environmental damage. So those are the key issues. So let us see how our scientists are making improvements in reducing pollution and reducing the impact on climate change while still using these traditional resources which are fossil fuels and trying to bridge the gap in the next few decades, simultaneously trying to innovate in utilizing solar energy in a much more efficient way, whether it's renewable right here on Earth, that is for photovoltaic or photothermal or solar based thermal, or even wind or more efficient use of or more efficient build out for generation of hydroelectricity. Apart from all of these things, can we really realize the dream of space-based solar? So these are the questions, but let's actually get into the real details of short-term options and what our scientists are actively doing and what you can possibly get involved in the next few decades in trying to address this energy crisis. Let's look into those details.